Hey everyone, welcome to this explainer. Okay, today we are tackling something incredibly exciting. We're going to take a look at the exact blueprint for taking a basic, run-of-the-mill generative chatbot and upgrading it into a fully autonomous, web-searching agentic AI using LangGraph. So if you've ever found yourself wondering how the real cutting edge of AI development actually pieces together under the hood, well, you're in the right place. We're going to break down all that complex code into clear visual steps.
Here's the roadmap for our build today. First, we'll look at the rise of Agentic AI. Then, we dive into the LangGraph foundation. Third, we'll tackle state and the fridge analogy. Trust me, that'll make sense in a minute. And finally, giving the chatbot tools. Let's jump right in.
Part 1, the rise of Agentic AI, moving way beyond standard LLMs.
So here's a critical question to kick things off. How do we give these LLMs persistent memory and real-time internet access? Because let's be honest, standard language models have a pretty massive flaw. They're basically amnesiacs. You ask a question, they give you an answer, and boom, the conversation is completely forgotten. Plus, they're stuck behind these strict training cutoff dates. If a model was only trained up to, say, December 2023, it has absolutely zero clue what happened yesterday. So how do we actually fix this?
Well, this is the massive paradigm shift we're currently seeing. On one side, you have standard LLMs. They are purely generation only, restricted by old, stale data, and completely forgetful. But then on the flip side, we have the future, agentic AI. This whole new paradigm is action-oriented. We aren't just generating text anymore. We are actively searching the web, pulling in live up-to-the-second data, like checking today's weather in Karachi, and most importantly, it actually has persistent memory to remember what you were chatting about 10 minutes ago. It's a total game changer.
All right, moving to part 2. The LangGraph Foundation. Let's look at the core architecture.
Okay, so absolutely everything in LangGraph starts right here with what's called the state graph. You can really just think of the state graph as your blank canvas or the foundational blueprint of your entire application. It essentially dictates the environment where your data structures, which in programmer speak we call state, will flow. It is the master plan governing how information travels from the very start to the absolute finish.
Now, obviously, on that blank canvas, we actually need to place our engine parts, right? In LangGraph, these components are called nodes. Simply put, a node is just a Python function that does one specific job. For example, you might have a single node whose entire purpose in life is just to invoke your language model. Say, firing up Gemini 1.5 Flash to process a prompt. These nodes are the heavy lifters actually doing the work in our application.
But here's the thing. Nodes can't just sit there all by themselves. They need to talk to each other. And that is exactly where edges come into play. Edges are your connection lines. Think of them as the electrical wiring that dictates the logical flow of your program. They literally tell the data where it needs to go after the start point, how to route itself between all those different nodes based on whatever conditions you set, and ultimately, how to arrive at the end of the process.
So bringing that all together, you really just have a simple 3-step construction process. Step 1, define the state structure. Basically, what does our data actually look like? Step 2, add your chatbot node to the graph. And step 3, connect your start and end edges to create a fully completed loop. Honestly, if you can nail those 3 things, you've successfully built the basic foundation of a LangGraph chatbot.
Which brings us to part 3, state and the fridge analogy. This is how we actually solve that LLM amnesia problem. Okay, I want you to picture a scenario for a second. Imagine 3 roommates, and they all share a single apartment fridge. Every morning, they all absolutely love making eggs for breakfast. So naturally, they all go to the market, they buy their own separate cartons of eggs, and they bring them back to stash in this one shared fridge. Now, in our graph, this shared fridge perfectly represents the application's state. It's that central hub where all the important data is kept.
But notice the stark contrast and how you can actually manage that fridge. In a standard programming setup, what we'd call an overwrite scenario, it is incredibly destructive. Roommate 1 puts their eggs in. Awesome. But then roommate 2 walks in, and they literally take roommate 1's eggs and throw them straight into the garbage just to make room for their own. No joke, this is exactly why your standard chatbots forget previous messages. The new message physically overwrites the old one. But to fix this, LangGraph brings in something called a reducer function. I like to think of the reducer as a super helpful kitchen manager. Instead of letting these roommates throw each other's food away, the manager takes the new carton of eggs and safely appends it right next to the old ones. Boom, everyone's breakfast is saved.
And you know what's cool? This translates directly into the actual code. LangGraph has a built-in reducer function called add messages. So whenever a new message comes in, whether it's from you or the AI, the reducer doesn't just nuke the previous chat. Instead, it carefully appends that new message to the existing list. Honestly, this reducer function is the absolute secret sauce to giving our AI reliable, persistent memory.
All right, let's move into part 4, giving the chatbot tools. Time for the advanced upgrades.
So here's a quick look at the tech stack we're actually binding to our system today. We're using Google's Gemini 1.5 Flash as our core LLM brain, mostly because it's just incredibly fast and highly accessible. We're also hooking up Langsmith running quietly behind the scenes, which is just fantastic for tracing logs and catching all those pesky bugs during development. And then, the star of the show, we're integrating Tavily. This is a dedicated web search API that acts as our agent's gateway to the live internet.
Now, to really grasp how tools function within LangGraph, I want you to visualize the tool. So in this case, our Tavily web search as a magic wand. It is this highly powerful artifact that can do amazing things, like magically fetching live, real-world data from the web on command. But here is where a massive point of confusion pops up for a lot of beginners. The LLM, our Gemini model, does not actually have hands. It literally cannot swing the magic wand itself. An LLM simply doesn't have the internal ability to run Python code or directly surf the web. Instead, what the LLM does have is the intelligence to know exactly when that wand needs to be used. So it spits out an instruction, essentially saying, hey, please use the search tool for this specific query. At that point, it's entirely up to our LangGraph system, specifically a designated tool node we've built in Python, to step up, physically swing the wand, execute that search, and bring the results back.
Let's map out how this builds into a flawless, logical loop. You ask a really complex question. Step 1, the LLM realizes, uh-oh, I don't know this. I need live data, and it outputs what we call a tool call. Step 2, our LangGraph routing catches this request and automatically redirects the flow over to our designated tool node. Step 3, that tool node safely executes the Tavily search right there on our local machine. And finally, step 4, the tool node packages up all those juicy internet results into a tool message and fires it right back to the LLM so it can formulate your final perfect answer. It's really just a beautiful, fully automated cycle of reasoning and acting. And I mean, just look at this transformation. On the left, before we added the Tavily search tool, our bot was pretty limited to basic historical queries. If you asked it for today's weather, it would just apologize and say it had no idea. But after binding the tool, our Agentic AI completely comes alive. As we saw in the source material, you can now ask it for the live weather in Karachi or to pull the current 2024 election results, and it autonomously decides to search the web, read through the articles, and serve you an incredibly accurate, up-to-the-second answer. That is the power of tools.
So there you have it. We took a basic, forgetful chatbot, and we officially wired it up with persistent memory using reducers and real-world action using tool nodes. You've now seen the exact blueprint. So I'm going to leave you with this one question to think about. Now that you actually understand the underlying mechanics of state, memory, and action in LangGraph, what Agentic AI are you going to build next? The possibilities here are literally endless. Thanks so much for joining me for this explainer, and happy building.